Greetings to everyone! Today you will see a teardown video of quite an unusual CD player made by Sony. But before I start, I'd like to remind you that you can subscribe to this channel where I'll be uploading new videos about home cinema and other hi-fi equipment. This is Sony CDP-XB930E CD player. I bought it from eBay a few weeks ago. It came in its original packing, even the original postage label has remained on the box. The original remote control is also present here. Player itself was neatly wrapped. After removing the foam wrap, it became clear that the player is well preserved and its condition is great. So why did I decide to tear down this particular model? It is because of the XB930E CD loading mechanism. It's quite an unusual solution which you are not going to come across very often. In this Sony player, it's not the tray that comes out when you want to load the CD, but the sled with the whole reading mechanism in it. Another interesting aspect is that the laser always stays stationary and the CD moves over it during the playback as opposed to working the other way around. Let's see how this player looks from inside. First of all, I have to remove the fascia from CD loading sled. Because if I don't do it now, I won't be able to remove the front panel later. It is not complicated. I just need to disengage slots and gently push the sled's fascia up. After it's done, I can close the tray and power down the player. Next, I can remove the top cover, which is fixed with 2 screws on the right hand side, 2 more at the rear, another 2 on the left, and last 2 at the top. Now I have to spread the cover sides a little bit outwards and lift it straight up. The inside of the player is split in 3 sections: power supply, CD drive, and audio part. In order to make my teardown a bit easier, I will remove the rear panel first. I'll start with unplugging the mains lid and then unscrewing 13 copper screws which are securing the panel. This will give me a better access to the rest of the components. The next logical step would be to remove the front panel, which is fixed with 4 screws at the bottom and 4 more at the top. As the front panel is still held with a pair of side clips, I can safely disconnect all the cables. I'll do the power switch first. On the main board, the first cable which I will disconnect is a control extension which links display PCB with Sony Link sockets at the rear of the player. Next goes the display board data ribbon cable, and that's the power supply cable which feeds display PCB. Now I can release the side clips and carefully remove the front panel. Now let's take a closer look at the front panel itself. I will remove the power switch first. Then I will unscrew the rotary switchboard and the keyboard. And after the display board is also unscrewed, I will lift all the 3 boards at once as they are still linked with each other. Here they are. All 3 PCBs from the front panel. Display board looks very neat and well engineered. On the opposite side of this PCB sits the system control chip. To be more exact, it's a CMOS 8-bit single chip microcomputer. Now I will dig even deeper and remove all the plastic parts of the solid aluminum panel. That may sound crazy, but later I will wash these parts with warm water and dishwashing fluid. This will allow me to clean all hard-to-reach areas perfectly. It wouldn't be possible with conventional cleaning methods. Now when the front panel is successfully removed and disassembled, I can carry on and remove the transformer board. Transformer is fixed directly to the chassis with 4 screws, and it sits on this solid copper pad. I couldn't find any scientific explanation about why this transformer was sitting on the pad made of copper. My guess would be because copper is non-magnetic metal and somehow it might limit the spread of electromagnetic interference inside the unit. I would like to add that this transformer has one primary winding and 4 secondary windings. Next in line is the power board. To extract it, I have to disconnect 2 cables which are feeding the main PCB and 1 more cable which is feeding the servo board. 4 screws undone and power board can be extracted. I really like the way how Sony engineers placed components on this PCB. Those parallel diodes and resistors looking especially neat. Another interesting observation about the power board is that the most current comes out rectified, except the current which feeds the fluorescent indicator tube. The vacuum fluorescent indicator tube requires alternating current power supply. Now, when I'm done with the power supply, I can extract the main board. First, I have to free the main board of cables. 2 power supply cables are going first. Next goes the cable which links main PCB with the servo board. Digital signal gets to coax and optical outputs directly through this cable. And the last cable remaining is the main ribbon data cable. Now I can undo 4 screws which are securing main PCB to the chassis. Finally, I can take a closer look at the main board. As I have mentioned earlier, digital signal from servo board gets into the main PCB through this connector here. It reaches coaxial and optical outputs while bypassing the rest of the circuitry. On the other hand, the main signal processing and conversion is done by these 2 chips. CxD8735N is a DSP. And Cxa8055M is a digital to analog converter. I have spent a lot of time looking for their datasheets, but I have never found them. While I was browsing through numerous AV forums, it became clear that I'm not the only one who had been looking for more information about them. The only useful bit of information that I managed to find was a block diagram of Cxa8055M digital to analog converter. After digital signal has been converted to analog, it's amplified by these 2 operational amplifiers. First one is M5238P dual low noise GFET input operational amplifier produced by Mitsubishi Electronic Semiconductors. And second operational amplifier in this chain is OPA2134A low noise low distortion operational amplifier made by Texas Instruments. This unoccupied area here is reserved for headphones amplifier, but it is not present in this model. That's all what I can say about the main board. Let's move on to the Servo PCB. Servo board is mounted right above the CD drive. Before I start unscrewing it, I have to unplug the remaining cables. Digital audio signal cable first, power supply cable next, and of course this ribbon data cable which links servo board with the sled PCB. After unplugging the cable which feeds loading motor, I can unscrew 4 screws which are securing the servo board's bracket. Oh, I nearly forgot to unplug the load-in switch. This switch detects when the sled is in a closed position. Now I'm going to separate servo board from the bracket so I could study it more closely. I'm finding this black mastic spread all over this player. My guess is that it is done to minimize any inner vibrations. The most important component on this board is this CxD8735N chip. It incorporates digital signal processor and digital servo block in one case. Inside this chip, the digital audio data splits into streams. One of these streams remains digital and gets to coaxial and optical outputs over that tiny gray cable which I have pointed out earlier. And the other stream travels through DSP, gets converted from digital to analog, and then it's amplified before it finally reaches output terminals. Also, you can see this BA6297 AFP chip, which is a 4-channel bridge-tied load driver that controls the spindle motor, sled motor, and as well as 2-axis tracking coils. And the third chip on this board is Cxa8055M. This integrated circuit incorporates an RF amplifier, a focus error amplifier, a tracking error amplifier, a PC circuit, and RF level control circuit. Basically, all data that is read from CD by optical pickup block passes through this chip. Great, I will carry on and get the CD mechanism out. 4 screws from the front side are undone. 4 more screws which are keeping CD mechanism and these brackets together are also undone. 2 metal brackets removed. And CD mechanism can be separated from the chassis. Now I will take off every part that is still attached to the chassis, so later I could give it a good clean with a dishwashing fluid and warm water. Finally, let's take a close look how the CD mechanism looks from the inside. In order to get inside, I need to take the drawer panel off. It is fixed with 2 screws at the front and 2 more screws at the back. Last thing to do is to release these 2 plastic claws and lift the drawer up. Next, I can remove the base unit, which is fixed with these 4 screws. Also, I mustn't forget this little screw which keeps these 2 ground wires attached and also secures the drawer shaft. I can now lift the base unit, which is sitting on 4 compression springs. I will put it aside while I finish disassembling the CD mechanism. To remove the sled base, I need to manually move it into an open position. I will carefully slide the shaft out and then simply lift the sled base. Next goes the load-in switch board. It's a very simple PCB with a single switch on it, and it provides important information about the sled position to the servo board. After taking the switch board out, the rubber belt can also be extracted. Next goes the loading motor. After 2 screws are undone, bearing can be removed, as well as the gear wheel. Limiter wheel and the slider pad are also taken out. To remove the lever, I have to release this clip first and then just simply lift it from its place. The last remaining part is this large pulley wheel. Finally, I can take a closer look at the base unit. I have decided not to carry on with disassembling it, as all components are exposed and can be observed clearly. So here you can see the stationary optical pickup. And that's the rack with the spindle board and spindle motor, which moves the CD relatively to the optical pickup. On the flip side, you can see the PCB, which accommodates the sled motor and otherwise works as a link between the servo board and optical pickup and spindle PCBs. All these components are fixed to this sturdy steel base. To ensure that this base unit is isolated from unwanted vibrations, these 4 rubber insulators are used. So here we are. These are all of the electronic components of the Sony CDP-XB930E CD player. And here are the other non-electronic parts. And of course the set of screws which I had to undo to tear down this player. Here you can see the inner side of the top cover. These black lines are the same black rubber mastic that I've mentioned previously. It is here to reduce the vibrations of the top cover. And now you will have a unique opportunity to see the mechanics of this player in action. I reassembled the player, leaving all the moving parts exposed, so you could enjoy this rare sight. As you have probably spotted that the CD wobbles while it spins during the playback. In this shot I tried to capture how optical pickup head follows the CD to keep laser focused. I slowed down the video 2.5 times so you could see this in more detail. So here we are. This player is now perfectly clean and reassembled. It was really fun to tear it down and study it from the inside. Hopefully you have enjoyed this video too. Don't forget to like and subscribe to this channel. Thanks for watching. Goodbye.